Hello students, I'm back again for class 9. We will do today maths chapter quadrilaterals exercise 8.1 and we will see question number 1, 2, 3 and 4. So let's begin. Students, so we have started a new chapter, that is chapter 8, and I hope you have gone through the video that I have uploaded regarding the introduction and concepts behind the chapter 8. And now we will start exercise 8.1 and we will see question number 1 first. Okay, so if you have seen the question, so there in the question the angles of quadrilateral are in the ratio. Okay, so a quadrilateral that will have 4 sides enclosed. So already they have given the ratio between the 4 angles. Okay, so what are the ratio? 3:5:9:13. So what we can take from here, this ratio, let the angles be 3x, then after 5x, then after 9x and 13x. I have multiplied the variable x with all the ratios. Okay, generally we do with the ratio component. Whenever it comes, we directly multiply the ratio with x or with any variables. Okay, so now we are getting that the 4 angles are 3x, 5x, 9x and 13x, and we already know, and if you have gone through my earlier video regarding the chapter 8, that was introduction chapter, so there we have seen that property or theorem that consists of that the angle, sum of the angles of a quadrilateral is how much? 360 degree. So we will start from there. So since sum of the angles of quadrilateral is 360 degree, so therefore, so what are the angles we have of a quadrilateral? 3x, 5x, 9x and 13x. So what we will do, we will add all the angles. We will add all the angles and we will be getting how much? We will be getting 360 degree. So after adding all these components, we will be getting how much? 30x. 3 plus 5, 8, 8 plus 9, then after 13 plus 13, we are getting 30x equal to 360 degree. So x will be equal to 360 divided by 30. So after cancelling, 3 1 3 12. So we are getting x is equal to 12. So now we already know that all the angles are in the variables form 3x, 5x, 9x, 13x. So now we will be multiplying the value of x 12 in all the angles. So therefore the angles are 3 into 12, then after 5 into 12, then after 9 into 12 and lastly 13 into 12. So we will be getting 4 angles. They will be 3 into 12, that will be 36 degree, and then after 5 into 12 it is 60 degree, then after 9 into 12 it is 108 degree, and last angle will be 13 into 12. How much it is? It will be 156 degree. So these are the angles that a quadrilateral consists of in question number 1. So I hope you have understand it. So now students, we will be doing question number 2 of exercise 8.1. Okay, so there if you see the question there in the textbook, it is given that the diagonals of a parallelogram. Okay, we need to understand the property, we need to revise the property of parallelogram whenever the questions comes from each of the type of the quadrilateral. So everything, every property, it should be in your mind before doing the solutions. Okay, so here I am writing the given part first. What is given here? The question is telling us that the diagonals of parallelogram are equal. So that means AC is equal to BD. Since it is a parallelogram, so we can write many things of the parallelogram. We can write the opposite sides are equal and they are parallel. Okay, so slowly whatever we want from the parallelogram, from the property of the parallelogram, we will take it. Okay, so now what is the property of rectangle and what is the property of parallelogram, as we need to show that to prove ABCD is a rectangle. ABCD is a rectangle. So ABCD, already we know that it is a parallelogram. So rectangle and parallelogram persist the same property. Okay, only one thing differs, that they will have the corner angle should be 90 degree. Okay, for whom? For the rectangle. So once we have shown that the corner angle, any one of the angle is 90 degree, then directly we can write that it is a rectangle. Okay, and so for that we have to work in the solution. So what we will take first, any two triangles that has the common side, we will take that one. Okay, you can take anything, any two triangles you can take using the common side. Okay, so I'm taking ABC and BCD as two triangles. So in triangle ABC and triangle BCD. Okay, so now using the chapter 7 congruence rules, we will follow that one, and we will see that what are the things they are equal. So we can write that this one BC is common between the two triangles. BC equal to BC. What is the reason? It is common. Okay, next what we can say, that AC is equal to BD. AC is equal to BD. So already it was given in the question, they were equal. And the third one, that we can take AB equal to CD. AB equal to CD. Why? Because opposite side of a parallelogram are equal. We have got already in the during the property of the parallelogram. So therefore three things we have got equal. So therefore we can write triangle ABC is congruent to triangle BCD. So what criteria we can write here? We have used the three sides that were equal, so three sides will be SSS criteria. Okay, so using this congruency, what we can conclude here, that ABC, angle ABC of this triangle ABC, and then after BCD of triangle BCD, they will be equal. So ABC is equal to angle BCD, and what we can write here, CPCT. So you have got already the full form, corresponding parts of congruent triangle. Okay, so now what we will do, using the result of this one, we need to remember another theorem, that is what we can use, since AB and CD are parallel. Why they are parallel? Because they are parallelogram. Okay, and in parallelogram opposite sides are parallel and equal. Okay, so AB parallel to CD, here we can write the reason here, ABCD is a parallelogram. Okay, and what we can use here in ABCD, AB and CD is parallel, and what we can take, BC as a transversal. So what was transversal? What is the meaning of transversal? They connects the parallel lines. Okay, so if I take, so what is the diagram is going on here, we are taking AB and CD is parallel. Okay, now what is transversal? Transversal connects the parallel lines. Okay, so if I draw here BC, so this will be our transversal. Okay, so and BC is the transversal. Okay, so now what we can take from this one, therefore this angle ABC plus angle BCD, ABC this angle and BCD this angle will be how much? It will be supplementary, that means it will be 180 degree. And this axiom or property we have already got, since angles in the same side of transversal are supplementary. Okay, so therefore what we can get here, so since here we can write, but angle ABC is equal to angle BCD. Okay, so therefore I'm writing here, therefore one of the angles or both the angles will be how much? 180 degree. So therefore angle ABC, I'm taking ABC, will be equal to 90 degree. And so as BCD will also how much? It will be 90 degree. Okay, so from using this result we can show all the angles is 90 degree by using the same solutions or same steps. So therefore ABCD is a rectangle. Okay, so this is the solution for question number 2. So I hope you have understand it. So now students, we will be doing question number 3 of exercise 8.1. So here is the diagram. So what is the question is asking us to prove ABCD is a rhombus. ABCD is a rhombus. So if you remember the property of rhombus, what was rhombus is, so all the 4 sides of the rhombus is equal. Okay, so many more properties were there using the diagonals. Okay, so but the basic thing for the rhombus, we need to show that all the sides are equal. Once we show all the sides are equal, directly we can write ABCD is a rhombus. Okay, so now what is the given part here? They are making, who are making the diagonals. The diagonals are bisecting, or you can say intersecting at O, and they are bisecting each other. That means OD is equal to OB and AO is equal to OC. And after bisecting also, they are making 90 degree. That means the right angle. Okay, everywhere it is a right angle. How many angles are there here? 4 angles are there, and every angle is a right angle. That means 90 degree. Okay, so using these things, we will do the solution here. So given is AC and BD bisect each other at right angle. Okay, so from this we can write OD is equal to OB and OA is equal to OC, and angles are every angles AOD, then after will be equal to AOB, then after that angle will be equal to BOC, and it will be equal to angle COD, and all will be how much? They will be right angle. That means 90 degree. Okay, so now for showing the all the sides of the quadrilateral ABCD equal, so what we can do, what to take first, that we need to take, always we need to take the 2 triangles. Okay, everywhere we have to show sometimes the angles, and sometimes we have to show sides are equal. So you should remember that to show any side or any angle, the 2 triangle wherever they consist of, they should be shown congruent. Okay, so here also I will start for showing the side AD and AB is equal. Okay, so now we will take the triangle in triangle AOB and triangle AOD. This triangle and this triangle we are taking. Okay, if I draw separately here, AOD and this one is B. Okay, these 2 triangles need to be shown congruent, and for congruent we need 3 things. They have equal in it. Okay, now I can take OA as a common side, so they will be equal, so they are taken as common. And then after, what we have got from the given part, that is OD was equal to OB. Why? The diagonals are bisecting each other. Bisecting means 2 equal parts. Okay, so here they are bisecting the sides or line segment, so that means they will be equal parts. Okay, so what we can write here, OB is equal to OD. It was given already. Then after, what we can take here, if you see the angle, this one and this one, they were all 90 degree. So I am taking only two pairs of angles, so they will be 90 degree. AOB is equal to AOD, each 90 degree, and also you can write given. Okay, so therefore we have got three things equal, therefore we can write AOB is congruent to triangle AOD. By which rule? So I have shown two sides equal and then after one angle equal. So I have the rule here or criteria, that is SAS. Okay, so using this congruency, what we can conclude here, that AB is equal to AD, and here we can write CP CT, corresponding parts of congruent triangle. Okay, this full form is very much important, so sometimes it comes for 1 marks, as I have told already in chapter 7. Okay, so now if I have got this one, AB is equal to AD, so using these two triangle or using these two triangle or using these two triangle, I can show, similarly I can show AB will be equal to BC, BC will be equal to CD, or CD will be equal to AD. Okay, so using this one as, this one you can take 1, this one as 2, this one as 3, this one as 4. So using this all 4, from 1, 2, 3 and 4, what we can get? AB is equal to BC, BC is equal to CD, and CD is equal to AD. So what was our motive? To show ABCD is a rhombus, and once we have shown all the sides are equal, directly we can write ABCD is a rhombus. Okay, everywhere whenever it is asked to show any type of quadrilateral, we need to know the properties of everyone. Okay, after knowing the property, we can find out that these things are equal, and that's why they are rhombus or parallelogram or rectangle. Okay, till now we have shown rectangle, and then after this one, rhombus. Okay, so I hope you have understand this one. So now we will be doing question number 4 of exercise 8.1. So this is the diagram, and this is the square that is given in the question. Okay, and what we need to show, so first we will write the given part, that ABCD is a square. ABCD is a square. So from this given part, we have to understand the property of the square, and using that properties we can use all the properties of the square in our solution. Okay, so now what need to be proved? There are two things to prove. One is the diagonals, that means AC and BD, they should be equal. Number 2, the diagonals bisect each other. Wherever they intersect, they bisect. That means OA is equal to OC and OB is equal to OD. Okay, they should bisect each other at right angles. So that means every angle here, they should be right angle. Okay, AOB, also angle AOB equal to angle BOC equal to angle COD equal to angle AOD. They should be how much? 90 degree. That means the right angle. Okay, so we can show any of the one angle that is 90 degree. So after that, that will be clear that everyone is intersecting each other at 90 degree, because since BD, if I imagine this BD as a line, so once it is 90 degree, so this will also be 90 degree, and opposite to that, if I this one take AC as a line or line segment, so it will have 180 degree, so this one will 90 degree, so it will be also 90 degree. Okay, so again if I take this one, so it is already I have shown 180 degree. Okay, so once I have shown any one of the angle that is 90 degree, I will be able to write that all are bisecting each other at right angle. Okay, so one by one we will be finding out everything whatever has been asked in this question. Okay, now we will start for proving that AC is equal to BD. Where is AC? This one is AC. and this one is BD. Okay, AC and BD. Okay, so if I draw the diagram here, so if I take this one ABC and BCD, two triangles if I take, and then after if I show two triangles as a congruent, so one of the part that is AC of this triangle, okay, and BD of this triangle will be equal by using CPCT. Okay, now we will prove the one. Okay, so we will take which triangle? In triangle ABC and triangle BCD. So ABC, in ABC and BCD, we need three things to show congruent. So first one, BC I will take as a common side and they will be equal. Okay, next what we can take, then after AB and CD will be equal. Why? They are the side of the square, and side of the square, all the sides of the square are equal, side of square. Okay, then what we can take? We can take the vertically opposite angle also. Okay, suppose AC and BD are two lines, so we can take these two angles. Oh, sorry, we are talking about ABC and BCD. So BC is common, this one is opposite side. Okay, and then after this angle ABC and BCD, both will be how much? They will be 90 degree, because every angle of a square is 90 degree, or they are in a right angle position. Okay, so therefore triangle ABC is congruent to triangle BCD. Okay, so which criteria I have used here? I have used SAS, two sides and one angle. Okay, so therefore what we can conclude from this one, so whatever things we need for question proof one, that is AC is equal to BD. So after showing this one, I can write directly AC is equal to BD. Why? It is CPCT. So first one is proved. Okay, next we will move for the next one. Okay, OA is equal to OC, OA equal to OC, and then after OB is equal to OD. So again we need to show two triangles congruent so that I can show these two sides are equal to each other. Okay, so let me see under which triangle all the sides are coming. So if you see nicely in the diagram that OA is from this triangle, OB is from this triangle, OC and OD are from this triangle. Okay, so I will take which triangle? These two triangle I will take. So in triangle AOB and triangle COD. Okay, so what are the things that will be equal? One, I can write AB is equal to CD because they are the side of square. Okay, and side of square means all the sides will be equal in square. Okay, AB is equal to CD. Then after what we can write? We can write AOB is equal to angle COD. Why? Vertically opposite angle. This also we have seen in chapter 6. Okay, so next, the last thing that need to be equal. What we can show equal? I can take this angle and this angle. Okay, or I can take this angle or this angle. Why? So suppose it is a square, not suppose, it has given already ABCD is a square. So ABCD is a square, so AB and CD opposite side will be parallel. Okay, opposite side AB and CD will be parallel, and if I draw the transversal here, this one, so this angle and this angle, they will be equal. Why? Because of the property alternate interior angle of a parallelogram, they are equal. Understand? So now lastly, what I can take from both the triangles, that angle AB, so I have to take up to here because our triangle is ABO. Okay, instead of ABD I will take what? ABO equal to angle, instead of up to here DB I will take CDO. Why? Because AB is parallel to CD and BD is transversal. Okay, so therefore they will be alternate interior angle. Finish. Now therefore triangle AOB will be congruent to triangle COD. And which criteria we will write here? See here, two angles has been shown equal and one side. So it will become criteria ASA. Okay. Now using the congruency rule, what we can show, we can write directly AO is equal to CO and BO is equal to DO. AO equal to CO and BO equal to DO. Okay, both can be written as CP CT. Okay, so from here, from these two things we can conclude that so AC and BD bisect each other. Okay, AB and CD, AC and BD bisect each other. That involves here, you can write here, that is AC and BD bisect each other. Okay, now we will move towards the last segment, that we need to show that they are bisecting each other at right angle or 90 degree. Okay, so we will do the last part, that is the showing of one of the angles, or they will bisect, AC and BD bisect at right angle. Okay, so what I will take here, I will take two adjacent triangles. Okay, AOB and COB, or you can say BOC, I will take here. Okay, and after taking these two triangle, after showing congruent between these two triangle, what I can say, this angle and this angle will be equal. Okay, and then after using equal between these two triangle, what we can say that after adding also these two triangle, it will be 90 degree, 180 degree. Why? Because it is above the line. So using linear pair axiom, I can show these two angles, after adding it will give us 180 degree. And if after showing congruent, if two angles are equal, then every angle will be 90 degree. Okay, so how it is possible? So I will write here, in triangle AOB and triangle BOC. Okay, so what are the things that is equal? First I will take the common thing, it is common. Then after AB and BC will be equal. Why? Side of square. So the last thing will be OB will be equal to OA is equal to OC, that we have proved already here in the second segment. Okay, AO is equal to CO, so AO will be equal to CO. Just proved, or proved above you can write. Okay, proved above. Okay, so now therefore triangle AOB will be congruent to triangle BOC. Okay, by which rule, by which criteria? So I have used three sides here to show equal, so there will be triple S criteria. Okay, so using this one, what we can show, AOB is equal to angle BOC by CP CT. And if I add angle AOB plus angle BOC, what I can get? I can get 180 degree. Why? Because of linear pair axiom. Okay, so if you see here, this angle plus this angle, they are adjacent angles in line AC. Okay, so they will be supplementary, that is 180 degree. Okay, so this shows that if I take AOB is equal to BOC, and if I add both that angles here, so that means that is angle AOB will be equal to BOC, and they will give us 90 degree. Okay, understand this procedure. Since AOB is equal to BOC, and if I add AOB plus BOC is 180 degree, that means both the angles will be equal, taking 90 degree each. Okay, So therefore what we can write, AC and BD bisect each other at right angle. Okay, so AC and BD bisect each other at right angle. Okay, so I hope you have understand this question number 4 solution. Okay, so again we will meet in the second video, next video, that will consist of many other questions of exercise 8.1.
So till then, thank you and take care.